Hello, my name is Ryan and my group member is Amanda. Our teaching philosophy is practicing inclusive teaching. Within the classrooms, teachers are bound to encounter a variety of different learners who will require different teaching strategies. As teachers, we have to consider a number of diverse situations that will force us to adapt our teaching methods so that students have the best chances possible of learning. For example, teachers would want to consider Gardner's theory of multiple intelligences and how their lesson would need to be multimodal in order to include all students. Our philosophy also involves social learning for students, as we believe that students understand the content they are expected to learn better when they can discuss concepts with their peers. Our demonstration will focus on students measuring plants for a grade 2 science and mathematics lesson. This lesson allows students to explore the effects of water and sunlight on plant growth in a collaborative and multimodal way. Students will have 2 plants each, one that they leave in the sun but don't give any water, and one that they water but leave in a closet away from the sun. Before they begin measuring the plants, students will engage in a think, pair, share exercise where they are asked the questions: how do you think each plant will be affected by the lack of sunlight and the lack of water? They will also be asked, what do you think is the best way to measure the plant? How will we go about measuring it? The part that I will be demonstrating is a teacher showing students how to measure their plants properly and record the information. While I measure the plant, I'm going to carefully describe using words what I am doing. This way, I am attending to the needs of both visual and auditory learners. After demonstrating how to measure the plant, I will also write detailed instructions on the board for linguistic learners. And finally, the students will get to measure themselves. This is for students who learn kinesthetically. They may not truly understand how the activity works until they're able to do it themselves. Alright, class. Now we want to begin measuring our plants. So, the first thing that we need to consider is what unit of measurement we want to be measuring our plants with. On our ruler, we're going to have 2 units of measurement. At the top here, we have centimeters. You'll be able to see it has a little cm to distinguish that this side is centimeters. On the bottom, we have inches. And if we look here, it says inch to distinguish that this side is inches. We want to measure our plants using centimeters. So, when we hold our ruler up to the plant, we have to make sure that we are using this side of the ruler. So what I'm going to do is I'm going to take my ruler like this, and I'm going to put the bottom side that starts with 0 centimeters right at the base of the plant. And I want it to start there because that's how we measure how much the plant has grown. From there, I'm going to look up to the very top of the plant, right here, and see how far up on my ruler that goes in centimeters. So if I look here, the very top of the plant goes just up to 12.5 centimeters. All right. So what I'm going to do now is on our charts where we are measuring all of our heights, we want to put, or I will put, 12.5 centimeters right beside my prediction. So my prediction, originally I thought it was going to be 15 centimeters tall, but maybe because it didn't have as much water as the ones that got water, this one didn't grow as tall. And so I'm going to get everyone else to do that. And remember, I'm going to be putting the instructions up on the board for everyone to see. I've written down all the instructions of what I just went through, and that's going to be written up on the chalkboard for everyone else to read, okay? Within our demonstration, the teacher is catering to visual, auditory, linguistic, and kinesthetic learners. Before the measuring begins, we also give students the chance to learn collaboratively through co-constructing processes. They are able to discuss their ideas about how the plants will grow without water or sunlight, instead of having a teacher just give them that knowledge. It's during the discussion that we can see Vygotsky's social constructivism at play, where students can engage in critical discussion with their peers about how the plants are going to be affected by the lack of essential resources. If we were to instead implement Piaget's individual constructivism and have the students consider the plant growth on their own, they may not come to the same conclusions as their peers, and they may miss out on some key learning. The other important psychological concept within our demonstration is observational learning, which falls under Bandura's theory of social cognitive learning. The students are watching me measure my own plant, and then they are also replicating it. For me to just tell them what to do may not be enough. They need to see how I hold my ruler, what part of the plant I start measuring from, and where I would end measuring it. Students will often learn how to do new things by mimicking their families, their teacher, or even other students. Questions. Will I be able to make all of my lessons be inclusive of everyone? No. Unfortunately, you may not be able to address every student's best learning style with each of your lessons. But, fortunately, most people are able to learn in a variety of ways. Someone who is a visual learner might also be able to learn kinesthetically or possibly linguistically. What should I do if students are struggling with measuring even after my demonstration? Well, first, you could encourage them to ask their peers for help. We want students to be able to rely on their peers so that they can all learn together. Alternatively, you could try scaffolding their learning by helping them with the measuring at first, and then later, the next time they go to measure their plant, you can see if they can do it themselves.